Hello everyone and welcome to JCE Connect. I'm Professor Rajendra Jotawar from Jain College of Engineering, and today we'll be studying about cloud computing. Starting with the first module as introduction, we have eras of computing, then we have cloud computing and class, under which we have vision of cloud computing, defining a cloud, closure loop, and cloud computing reference models. Later we have historical developments, under which we have distributed systems, virtualization, Web 2.0, service-oriented computing, and utility-oriented computing. Without further ado, let's start with eras of computing. The computer era, which began in 1940s, started with sequential era, or rather sequential computing era. Later on, within a decade, parallel computing or distributed computing also followed it. In the beginning of sequential era, we can see that the first thing that came into existence, or rather picture, was architecture. Later, compilers, applications, and problem solving environments. What are those? In depth we will be studying in the further chapters. Next, we have computing or cloud computing at a glance. In the late 60s, when internet was still booming, everybody thought of accessing it, but it was not that easy. But a chief scientist in ARPANET named Leonard Kleinrock stated that as of now, computer networks are still in their infancy, but as they grow up and become more sophisticated, we will see them spread computing utilities across the country, providing services to the individual homes and offices. Computing services will be readily available on demand, just as any other utility services such as water, electricity, telephone, etc. Users only need to pay to the providers only when they are accessing the services. Customers no longer need to invest heavily sorry customers need not have to invest heavily in the very beginning. Investment in the beginning of any business or any startup is not that appreciated, because as you all know, customers no longer need to invest heavily or encounter difficulties in building and maintaining a complex IT infrastructure. Next, we have vision of cloud computing. Cloud computing allows anyone with a credit card to provision virtual hardware, runtime environments, and services. When I say virtual hardware, this is a bit more advanced than rather physical hardware. In physical hardware, we can touch it, we can feel it, anything and everything what basically physical means. In virtual, it is not actually present with you, but rather somewhere else which you can access it. These are used for as long as we need. Users only have to pay for what they use and whenever they use. The entire stack of computing systems is transformed into collection of utilities which can be provisioned and compressed together to deploy systems in hours rather than days. So if you want to start up with the cloud computing, or rather hosting a cloud computing environment to provide services, it can be done virtually within hours of matters, rather than if you are doing it physically or setting up an entire lab or set of systems, it might take days, whereas virtually it can be done within hours. The use of cloud computing is often limited to single service at a time, or more commonly a set of related services offered by the same vendor. The lack of effective standardization efforts makes it difficult for to move hosted services from one vendor to another. When it was in the beginning of cloud computing, it was depending on the provider. Each provider provided a specific type of services. Now it's not like everyone provided all kind of services. For example, let's say in the early beginning stages, Google only provided storage related services, whereas somebody else provided only computation related services. In today's world, it is not like that. We can move from one service provider to another service provider, as they have different platforms of service providing. They are not sticking up with one particular service provider. Next, we have defining a cloud. Now, what basically cloud means? It's a Type of parallel and distributed system consisting of collection of interconnected and virtual computers that are dynamically provisioned and presented as one or more unified computing resources based on the service level agreements established through negotiation between the service provider and the customers. What does this mean? It's a combination of parallel and distributed computing consisting of physical as well as virtual computers. Physical computers are the ones which we can use, as we all know, as well as virtual are virtually hosted computers. Combination of these two located at single place or multiple different places by service providers and providing services to the users, that is we, through service level agreements. What are the service level agreements? It is nothing but give and take of we will be using your services provided we will be paying you this much of amount. That is nothing but in general service level agreement that is done between the service providers and the customers. We can define three criteria for this, or rather say how a service is delivered in cloud computing. A service is accessible via web browser or web service applications or APIs. Zero capital expenditure is necessary to get started. You pay only for what you use. That means whenever to start or access this service, we can use it through web browser. Okay, then we don't have to invest anything. You just have to have an internet connection on your system. That can even be your mobile phones. Today smartphones are smart enough or more powerful enough than any laptops or systems. So we can access it or access these cloud computing services through web browser. We don't have to invest anything. We don't have to buy an entire load of computers with a huge amount of RAM, hard disk storage, processors and everything. We don't have to invest anything. We only need to access it. We are kind of renting the services on whatever we need. Users only have to pay for whatever they use. You don't have to buy. For example, if you want to rent a bike, you want to go somewhere, you just go rent a bike for whatever you use. Whatever type of bike you want, you can rent it and pay as per the charges. That's it, done. You're not buying the vehicle, you're just renting it for some time, using it and then returning it back. In the same way, cloud computing is also same as that. Whenever you say cloud computing, there are multiple things coming up in front of us, or rather in the mind. For example, no capital investment, SaaS, PaaS, IaaS, elasticity, scalability, and many more. What exactly are those? Cloud computing is a type of computing that relies on shared computing resources rather than having local servers or personal devices to handle applications. An internet plays a fundamental role in computing since it represents either the medium or the platform through which many cloud computing services are delivered and made accessible. Cloud computing refers to both applications delivered and services over the internet and the hardware and the system software in the data centers that provide those services. It's a model for enabling ubiquitous, convenient, on-demand network access to shared pool of configurable service resources that can be rapidly provisioned and released with a minimum management effort or service provider interaction. Now, whenever you search for cloud or cloud computing, you can see that all these pop up. That is Microsoft Azure, Google Cloud, iCloud, Amazon Web Services, which is AWS, Dropbox, and many more. What are these? These are all the service providers. You knowingly or unknowingly you might have used some of these. For example, Dropbox and Google Drive or Google Photos. What are those? You might have used it for sharing of photos, videos, or any other documents. For example, let's say if you are mailing or sending some of the informations or some images, some documents to someone, you are mailing it to someone through Gmail. Now Gmail has a provision of 25 MB within mail. That means if you're sending a mail, you have 25 MB of space wherein you can upload that much amount of data, files, images, videos, or anything which is equal to or less than 25 MB. Anything more than that, a pop-up will appear saying that to upload that particular document to Drive or Photos to Google Photos, so that it can be uploaded there, and then a shareable link is generated which will be shared in your mail, so that the person who is receiving it or the person to whom you are sending it can access it from your Drive. You might have, this is nothing but Google Cloud. The same way we have Microsoft Azure, services provided by the Microsoft. In Google, you might have used Google Drive, Google Photos, and many other things that are Google Cloud. Okay, iCloud is for Apple, Amazon Web Services. This is something recently which provides web services for hosting and maintenance of websites or any other heavy duty services. Next, let's take a closer look on what cloud computing actually is. Cloud computing is helping enterprise, governments, public and private institutions, and research organizations to shape more effective and demand-driven computing systems. Access to as well as integration of cloud computing resources and system is now as easy as performing credit card transactions over the internet. Practical example of such systems exist all across the market segments. Large enterprises can afford some of their activities to cloud computing based systems. For example, let's say there is a already established business in the market. They can afford to have the physical systems. If they want some extra computational power, they can afford it. But that doesn't mean that they have to. Using the cloud computing, they can access it on rental basis. They can use it as they want. They can use the computational power as they want. Computational power, that doesn't mean only the client system. Even the servers are also servers also comes under this. Small businesses or small enterprises or startups, they don't have to think twice for putting and beginning investment. They don't have to invest much of a capital investment in the very beginning. They can simply rent it or access the services through cloud computers. System developers don't have to concentrate on business logic, don't have to concentrate on infrastructure management. They can only concentrate on business logic, how to work the things out. End users can have their documents accessible from anywhere and anyhow. These are few of the examples, practical examples we can see in the markets today, but there is more for this. Cloud computing can be categorized into three major development models: public clouds, private clouds, or also known as enterprise clouds, and hybrid clouds. Starting with the public cloud is defined as computing services offered by third-party providers over the public internet, making them available to anyone who wants to use or purchase them. They may be free or sold on demand, allowing customers to pay only per usage for CPU cycle, storage, or bandwidth they consume. Public clouds can also be deployed faster than on-premises infrastructure and within an almost infinitely scalable platform. Every employee of the company can use the same application from any office or branch using their device over the internet. While security concerns have been raised over public cloud environments, with when implemented correctly, the public cloud can be secure as most effective managing private cloud. Next, we can see private clouds. Private clouds is defined as computing services offered either on the internet or private internal network. The only to select users instead of general public. Also called as internal or corporate cloud, private cloud computing gives businesses many of the benefits of public cloud, including self-services, scalability, and elasticity, with an additional control of customization. Available from dedicated resources over the computing infrastructure hosted on premises. In addition to private cloud, deliver a higher level of security and privacy through both company firewall and internal hosting to ensure operations and sensitive data are not accessed to third-party providers. Last one is private clouds. Hybrid clouds. A hybrid cloud is Cloud is a computing environment that combines public cloud and private cloud by allowing data and applications to be shared between them. When a computing and processing demand fluctuates, hybrid clouds gives businesses the ability to seamlessly scale their own premises infrastructure up to the public cloud to handle any overflow without giving third-party data centers access to the entirety of their data. Organizations gain the flexibility and computing power of the public cloud for basic and non-sensitive computing tasks while keeping the business critical applications and data on premises safely behind the company firewall. Using the hybrid cloud not only allows companies to scale resources, it also eliminates the need to make massive capital expenditure to handle short-term spikes in the demand as when the business needs to free up local resources for more sensitive data or application. In short, these are the three major cloud computing development models. Public clouds are accessible from anywhere by anyone, which provides application storage, development runtime platform, government cloud services, etc. Private clouds are more like it's a private network wherein it will be hosted or handled within an organization itself. It can be restricted to a building itself or multiple branches across different places. Only selected users can access it with their login credentials. For example, a student viewing his results through university website. That service is hosted, or rather the document or data is present in the server of a university, wherein student is accessing from a different place on his or her own device using their USN. Lastly, we have hybrid clouds, which is a combination of public as well as private. This provides the feasibility, or they gain flexibility of computing power of public cloud, whereas security of private clouds as well. Lastly, we have cloud computing reference models. Cloud computing references or services offerings are divided into three major categories: infrastructure as a service, platform as a service, and software as a service. Starting with the first one, infrastructure as a service, or IaaS in short. These are solution deliver infrastructure on demand in the form of virtual hardware, storage, and networking. Virtual hardware is utilized to provide compute on demand in the form of virtual machine instances, which means hosting that entire hardware or storage or networking virtually rather than setting up physically. Uh, you can say it as hosting an entire set of hardware or set of data centers virtually. That means it is not physically present, but making or creating a delusion of it is existing somewhere and accessing services through that. These are created at user's request on the provider's infrastructure, created on demand of the user on providers or service providers infrastructure, and users are given the tools and interfaces to configure the software stack installed on the virtual machines. Second one is platform as a service, or also known as PaaS. These are the PaaS solutions are the next step of the stack. They deliver scalable excuse me, they deliver scalable and elastic runtime environments on demand and host the execution of applications. These services are backed by the core middleware platform that is responsible for creating the abstract environment where applications are deployed and executed. It is the responsibility of the service provider to provide scalability and to manage fault tolerance, while users are requested to focus on the logic of the application developed by the leveraging the provider's API and libraries. Lastly, we have software as service, also known as SaaS. These solution providers applications and services on demand, which provide applications and services on demand. Most of the common functionalities of desktop applications such as office automation, document management, photo editing, and customer relationship management software are replicated on providers' infrastructure made more scalable and accessible through browser on demand. These applications shared across multiple users whose interaction is isolated from other users. The SAS layer is also the area of social networking websites which leverage cloud based infrastructure to sustain the load generated by the popularity. As you can see here, as the layer goes up and up, for example from infrastructure as service to platform as service and lastly to SAS, we can see that control over the data or control over that service goes on decreasing. In depth we will be studying in the further chapters. That's all for today's class. In the next class we will be studying about historical developments, under which there will be distributed systems, virtualization, web 2.2, service oriented computing and utility oriented computing. Thank you.